Swayam Prabha. Digital India. Educated India.
Yogah karmasu kaushalam.
Hello students, my name is Ishank Shanolkar and today we will be discussing the topic Demand Analysis 2, which is an extension of the first part. Let us start with the objectives of this session, that is demand function and demand equation, consumer surplus, types of demand forecasting, methods of demand forecasting which help in the overall analysis of demand. So let us start with the first topic, that is demand function and demand equation. Let us look at the concept of demand function. A demand function is a mathematical expression that shows the relationship between the quantity demanded of a good and the various factors that influence it. Let us look at the general form of demand function. The demand function as given is read as QD is equal to f of P, Y, P, R, T, E, N and G. So here when you read it as QD is equal to f of or function of. Essentially what a function means is it shows the dependence of one variable on another. The variable on the left hand side that you can see, which is QD, that is quantity demanded, is dependent on all these other factors or other variables. Let us look at all these other variables upon which the quantity demanded is dependent on. So first you have price, which is denoted by P, Y denotes the income of the consumer, PR denotes prices of relative goods, T denotes tastes and preferences, E denotes the expectations about future, number of consumers are shown by the variable N, and G represents the government policies. So all these variables determine demand, that is what is shown by a mathematical function, that is QD as a function of all these variables. Again, it is like saying quantity demanded is dependent on all these other factors. Now let us look at the linear demand function. So the simplest form of demand function is linear, which can be expressed as QD is equal to A minus BP, where A is the maximum quantity demanded when the price is equal to 0. This is also called the intercept of the equation. So the intercept is defined as the left hand side variable QD in our case when the right hand side variable, that is P, is equal to 0. A and B are called parameters which are constant numbers. P goes on changing, which makes it a variable, and QD accordingly changes, which also makes it a variable. So in this linear function we have two variables and two parameters. When the value of P is equal to 0, you are left with A. That gives you QD is equal to A. So what you have is, what is the quantity demanded when the price is equal to 0? That will be the number represented by the symbol A. Now if we look at the symbol B, it represents the rate of change in quantity with respect to change in price, that is also known as the slope parameter. Now imagine the intercept first, that is when the price is equal to 0, what is the quantity demanded? That will give you a point in your graph. Now as the price changes from 0 to 1, the quantity demanded is going to fall, as we know from the law of demand. So this gives you another point on the graph. As price increases or falls from one point to another, the quantity demanded is going to change further. For example, if price increases from 1 to 2 now, 2 to 3 and so on, the quantity demanded will keep on falling. And this will give you, when you join all these points, this will give you a straight line or what we call as a linear demand curve. So this is typically the definition of a linear demand curve which is represented by a general equation of QD is equal to A minus BP. Let us look at an example of the linear demand curve. So, a linear demand curve as shown in the example will tell you different quantities demanded when there is different price. So, once the price is equal to 0, you will have a certain amount of quantity that you can calculate from this function. For instance, when the price is equal to 10, the quantity demanded can be achieved by replacing the value of 10 instead of P, that is 100 minus 2 multiplied by 10, because the price at this point is equal to 10. That gives you 80. Now, when the price increases all the way to 50 units, you have the equation as QD is equal to 100 minus 2 into P, that is 50, giving you 0 units. So, your linear demand function, as we saw in general form, is QD is equal to A minus BP, and in an example form, when you have the values of A and B which are constants, taking them as 100 and 2 respectively, you have QD is equal to 100 minus 2P. So, as P changes, you will have the value for QD also changing, and when you plot it on a graph, you will get a straight downward sloping line as the demand curve which we saw in the last session. So, this way you can practice drawing a linear demand curve as well. Now, let us get an idea about non-linear demand functions. Real world demand relationships may not be linear in nature, and they may show us a non-linear trend. For example, we may have something called as a power function, that is QD is equal to A multiplied by P to the power of minus B, or an exponential function QD is equal to AE to the power of minus BP. So, we have a logarithmic function which can be shown as QD is equal to A minus B log of P. So, the essence here is that these functions, when you go out and plot, or when you put values of P from 0, 1, 2, 3, 4, that is, as there is an increasing P, you will still observe that the quantity demanded will keep on falling, but the graph that you get will not be a straight line. It may be a curve. It will be a different shape of a curve, which shows that the rate of change is different against a linear demand curve. Now, let us move to the market demand function. Market demand function is derived by aggregating individual demand functions. The formula for that is Qm is equal to summation Qi. The symbol of summation is also called sigma. So, Qm represents the market demand and Qi represents individual demands, M for market and I for individual. So, if you have, let us say, 3 individuals in your market, for example, Q1, Q2, Q3 will be the quantity demanded by individual 1, individual 2 and individual 3. Suppose individual 1 demands 3 units at the price of 5. Suppose individual 2 demands 2 units at the price of 5, and individual 3 demands 3 units again at the price of 5. So, the total is going to be 3 plus 3 6 plus 2 8. So, the market demand is nothing but an addition of all 3, that is, at the price of 5 in the whole market, which is combination of 3 individuals, you will have the total market demand to be equal to 8. That is the idea of market demand and what the formula showed, that is Qm is equal to summation Qi. Now, we move on to inverse demand function. Inverse demand function is flipping the original demand function and getting it in terms of price. That is saying, like, instead of quantity demanded as a function of price, we invert it and say price being a function of quantity demanded. That is what is expressed over here, that is P is equal to F of Q, or here we are saying price is dependent on quantity. We are just getting it in that format. This is particularly useful in determining the maximum price consumers are willing to pay for a given quantity. Now, if we move to the concept of consumer surplus, let us look at the definition and concept, because that is based on willingness to pay. Consumer surplus is the difference between the consumer's price that they are willing to pay for a good and what they actually pay. It represents the net benefit or satisfaction gained by the consumers. If we look at the mathematical definition, then it is the total utility minus the total expenditure. Talking about measurement of consumer surplus, we have the fact that consumer surplus can be measured using the demand curve. So, if we imagine it graphically, then consumer surplus would be the area between the demand curve and the price line above the market price. So, as you can see from the graph, suppose the market price is equal to $20. Consumer surplus is the area above the price line, that is $20, up to the demand curve, because let us say if you plot or look at a point in between 20 and 50, that is suppose $40. Then when you join the line to the demand curve, you say that there are some consumers in the market who would still demand the product at $40, that is they value the product at $40. So, if they have to pay a price of $20 for a product for which their value is equal to $40, it is definitely a gain for them. That is, they have to pay a lesser price as compared to their willingness to pay. This is what we call the concept of consumer surplus, and we will discuss this in detail in another chapter. Now, moving on to the formula of a linear demand curve for calculating consumer surplus. As you can see, consumer surplus is a triangular shape. So, we can calculate consumer surplus by the formula of half into base into height of the triangle that you saw. So, base is equal to the quantity purchased, which is on the x axis, height is equal to the maximum price, which is on the y axis. If we take an example for the calculation of this, then suppose the demand function Q2 is 100 minus 2p and the market price is 20. So, in this case, the total quantity demanded is going to be 100 minus 2 multiplied by 20, that is 60 units. The maximum price when Q is equal to 0 is 50. What about the consumer surplus? So, the total consumer surplus in this market would be half into base, that is the quantity demanded, which is 60 as we calculated, into height, that is the gap from the highest possible price and the current market price, 50 minus 20. This gives us a positive value of consumer surplus of 900 units. Now, let us move to the factors that affect the consumer surplus. So, first is price level. Lower prices increase the consumer surplus. Income. Higher income may increase willingness to pay and may lead to changes in consumer surplus. Then availability of substitutes. More substitutes reduce consumer surplus. Essential goods often have a lower consumer surplus because you are willing to pay a lower price for them, and the price that you get is usually not very low as compared to what you are willing to pay. So, the gap between the price that you are willing to pay and what you actually pay is very less. So, essential goods have a lower consumer surplus. Since we have had this discussion, now let us move on to the applications of consumer surplus. First is welfare analysis. Measuring economic welfare and policy impacts is something that can be assessed using consumer surplus. Then it also helps in determining optimal pricing strategies. Further, it helps in evaluating market performance and assessing impact of taxes and subsidies, that is government policies. Now, let us look at another concept, that is producer surplus versus consumer surplus in contrast. While consumer surplus benefits buyers, producer surplus benefits sellers. The total economic surplus, that is consumer plus producer surplus, indicates the overall market efficiency. Moving on to the third topic in our session, that is type of demand forecasting. Demand forecasting is crucial for business planning, inventory management and strategic decision making. First, we have demand forecasting on the basis of time period, which is also termed as short term demand forecasting, which is up to 1 year. It is basically used for operational planning, inventory management, production scheduling and cash flow planning. Then you have medium term forecasting, which is between 1 to 5 years. This is useful for capacity planning, budget preparation, marketing strategies and human resource planning, which are typically medium run objectives of a firm. Then you have long term forecasting, that is beyond 5 years. This requires strategic planning, capital investment decisions, market expansion and technology adoption, which is the plan of a firm beyond 5 years. It is not in the short term, but it is in the long run. Next, demand forecasting is also done on the basis of level of details. First, we have macro level forecasting, which includes industry-wide demand or assessing national or regional markets, economic indicators or government policy impacts. If we look at micro level forecasting, then we have individual product demand, specific market segments, customer specified demand or seasonal variations. In terms of nature of goods, the demand forecasting can be done for durable goods, that is longer replacement cycles, economic conditions impact, credit availability influence and technology change effects can be assessed. In terms of non-durable good forecasting, regular consumption patterns, income sensitivity, seasonal factors and brand loyalty and its impacts can be known. Further, we also have service forecasting, that is immediate consumption, quality perception, personal relationship, economic cycle sensitivity are assessed by this method. Now we move on to different methods for demand forecasting. First, we have qualitative methods. First method is under qualitative method is expert opinion method. This includes consultation with industry experts, executive judgment, sales force estimates, and it is useful when historical data is limited to us. The next technique is called Delphi technique, which is structured expert consultation. Anonymous expert opinions are sought, iterative processes to reach consensus is sought after, and it reduces individual bias. Market research is also a part which includes consumer surveys, focused group discussions, and test marketing can also be done to get direct consumer feedback. Consumer intention surveys display the purchase intention of the consumers, buying behavior can be analyzed, customer satisfaction surveys are floated, and brand preferences are studied. Now, if we move to quantitative methods, then you have time series analysis or trend analysis, that is identifying long term patterns. Seasonal analysis includes regular cyclical patterns. Cyclical analysis is the analysis of economic cycles and its impacts. Irregular variations or random fluctuations are also studied in this kind of an analysis. One of the techniques under time series is moving averages, that is under that you have a simple moving average, weighted moving average, exponential smoothing, which are useful for typically short run forecasting. Then you also use regression analysis such as simple linear regression, multiple linear regression, polynomial, which help you to identify causal relationships between demand and all its other factors. Next, you have some complicated or complex models which are called econometric models, where you can model the relationship between multiple variables, and it allows you to look at economic theory, also some statistical validation which is required in order to conclude. If we look at the causal methods, then the leading indicators that we have are economic variables that change before demand changes. For example, GDP, unemployment rate, confidence of the consumers and so on. These could provide early warning signals for forecasting. Further, we also have barometric method which uses related series to predict demand. Economic barometers are used, industry specific indicators are used, and government statistics are utilized. If we consider another technique called input-output analysis, then inter-industry relationships are observed, supply chain dependencies are studied, and economic multiplier effects are seen. This helps in regional economic planning and forecasting of demand for regions. If we summarize the session, then we can say advanced demand analysis encompasses several sophisticated concepts that are essential for modern business decision making. Mathematical modeling, that is demand functions providing precise relationships between variables, consumer welfare, studying consumer surplus that measures the benefit to consumers, and forecasting techniques, various methods that help predict future demand patterns. This will help business students in pricing strategies, that is price discrimination, and the study of price discrimination, which we will take up in the next session in detail, that allows businesses to maximize their revenue. These advanced concepts build upon basic demand theory to provide business students with practical tools for real world application. Understanding these principles enables better strategic planning, pricing decisions, and market positioning in today's competitive business environment. I hope you understood and enjoyed the session. We will continue with Demand Analysis 3, where we will go further with this concept. Thank you so much.